Okay, we have another example with IVs running ahead or behind schedule. This is on page 29 from the packet. And this problem's very similar, except for now the volume is described by what's left in the bag rather than what's been infused in the patient. And I still will actually disregard this and look, as we did before, in terms of the patient, the actual infusion, if it's greater than the scheduled infusion, this is going to mean the IV is running ahead of schedule. And if the actual infusion is less than the scheduled infusion, this will mean that the IV is running behind schedule. I think it's easier to think in terms of what's going into the patient, but you can decide and judge for yourself what you think's easiest. So in this example, we have 1.5 liters normal saline IV to run for 6 hours with a drop factor of 20 drops for every milliliter. And after 2 hours, there are 1,100 milliliters remaining in the IV. So we're going to figure out the flow rates and then make a judgment on whether the IV is ahead or behind schedule. So we know flow rates are volume per unit time. So for milliliters, we're going to want to find our volume in milliliters, and the 1.5 liters is going to be equivalent to 1,500 milliliters after we multiply by 1,000 and move the decimal over 3 places. So that's our volume. And our time here is to run for 6 hours. And we can find out the milliliters for 1 hour by dividing. We'll say 6 goes into 15 2 times, so it'd be about 200. And I think if we calculate this, it comes out to be 250 milliliters per hour. All right, but we want, since this is a gravity feed, we want our flow rate in drops per minute. So we'll take our 250 milliliters for every 1 hour and look and say, oh, we got all kinds of work to do. Instead of milliliters, we need drops. Instead of hours, we need minutes. So we can trade in that 1 hour for 60 minutes. And that's not too bad. And then the milliliters, to get to drops, we'll need the drop factor of 20 drops per milliliter. And if we multiply that, you'll see the units of milliliters will cancel out, and we would calculate the number of drops. And looking at the units, we'll have drops on the top and minutes on the bottom, so this would be drops per minute on there. And we'll multiply horizontally across to see what this comes out to be. And I'm going to do some canceling to help estimate. 20 goes into 60 3 times. And I know 3 goes into 25 8 times. So this is looking to be about 80 drops per minute. And I think if we calculate it out, this will be 83.3 repeating drops per minute. And then so after we hit equals on the calculator, we'd say, yeah, that seems like a reasonable value. We were thinking about 80. And we'll round this to the nearest whole number because we can't really count a 0.3 of a drop. And we'll say 83 drops per minute was scheduled by the physician.